Hey there, guys. I'm Shami, and today we're going to be talking about rational inequalities. Rational inequalities are solved in this sort of format. So, you might see a problem very similar to this, or even more complex than this. So, this is a basic problem that we're going to solve. So, to find what this rational inequality could equal to, so what this x on both sides equals to, we have to first understand what it means to be greater than 0. So to be greater than 0, our x values both, they have to match up. And together, this division of this x plus 1 divided by x minus 2 should be greater than 0 and not include 0. So if we were to draw that on a graph, let me make that more clear. So if we were to draw that on a graph, let's say this was -1, this was 2, then our x value cannot be these. So open circle at these, so it cannot be these two. So it can either be in between to the left or towards going towards negative infinity or towards positive infinity. That's what we're trying to solve here. So by basis, this x plus 1, x minus 2 can be solved in multiple manners, and that's what we're going to be talking about today. So let's plug in a number. Let's just randomly plug in 0, right? So if we were to plug in 0, we would get 1 over -2, right? But that is not equivalent to 0. Let's plug in a number that is going towards negative infinity, so towards the left of -1, like -2. So -2, if we were to use it in place of x, we would get -1 on top over -4. So that would give us 4, which is confirmed greater than 0. So we know this side gives us a positive number. So we know this side gives us a positive number. Let's try on the other side, so towards 2. So let's try 2. No, we cannot try 2, sorry. Let's try 3. So that would give us 4 over 1, which is just like the last one, 4. So that is confirmed greater than 0. So this side is also positive. So that means that our x value is somewhere between infinity, comma, -1, union. These are not brackets, these are, say, parenthesis. This is also a parenthesis. Union 2, comma, infinity. And like we already calculated, if it were 0 or some other number like 1, we would get a negative value. So we would get a negative value there. So that is how you would solve rational inequalities. We're going to move into solving polynomial inequalities. So how do we solve this polynomial inequality? So we're going to use our normal method, where we're going to bring them all to one side. I believe there's only one method, but there might be some others. But this is your usual simple method that gets you directly to the answer. So now we need to solve for the x values that are not included not give us a value that is greater than 0. So now we would, like if you were to not know, then we would take -10, split it into two values, 5 and -2, so that we can use it as -2 plus 5. So these values would not be included in our x values. So on the number line, our values would be 2, -5. And we're trying to find which sides or which part of the number line makes this entire equation a valid positive number as a total. So which x value will make it a positive number? So we have excluded -5 and 2 because they will end up being exactly 0. Now we're going to try numbers from either side of the number line heading towards positive infinity or negative infinity. So let's try, let's say -6. So -6 squared is 36, and then 6 times 3 is 18, minus 10 is 44, which is automatically greater than 0. So we can already start writing our answer as negative infinity, comma, -5, not included. These are both parentheses, not brackets. Next, we're gonna try a number that's on this side. So something like 3. So 3 squared is 9. 9 plus 3 times 3 is 9. Minus 10 gives you 8. And 8 is still greater than 0. Just to make sure, we're going to try a number from the middle, like let's say -4, just so that it can be simple. -4 squared is 16. -4 times 3 is -12. And minus 10, that gives you -6. So that is not greater than 0. So that automatically means that our answer is negative infinity, comma -5, union 2, comma infinity. Thanks for watching, guys.